In this section, we want to talk about approximating area. But in order to do that, we first need to talk about sigma notation. Now, when you look at this word sigma, sigma is really a Greek letter. So this is the Greek letter for S, capital S, actually. So there's two sigmas. There's, this particular sigma is capital sigma. And this notation means something very particular. So when we look at this notation, the sigma actually means sum. So this means sum. And basically, this letter I is an indexing variable. So let me put a little arrow here like this, and this is an indexing variable. Okay, this letter N here, this tells us what we're going to add up to. So this is we're in this particular case, we're starting when I is equal to 0, and we're ending where I is equal to N. And we're counting through using integers. So we're going to have really N plus 1 terms here. Now, to the right of the sigma is going to be some expression that depends on N. So I think it's easiest to understand the sigma notation by looking at some examples. So let's take a look at this first piece of sigma notation right here. So our I is starting at 1 and it's ending at 5. And the sigma means we're going to add a bunch of numbers together. And those numbers, in this case, are just going to be the i's themselves. So when I is equal to 1, we put a 1 plus. Now the next step is I equal to 2, we put a 2, and then we put a plus. And then I would be equal to 3, we put a 3, and then we put plus. And then when I is equal to 4, we put a 4, and then add. When I is equal to 5, we put a 5. And we just stop there. Okay? So let me give you an additional example. Let's say that we have something that looks like the summation as I goes from 1 to, or let's make it go from 3 to 5, and let's have it be I squared. All right? So if I were to write out what that means in sigma notation, that would be the first number would be 3. So we put a 3 in for I, and we would get 3 squared. The sigma means plus. You're going to add together all the numbers. When I is equal to the next number, which is 4, you get 4 squared is the second term. Plus, when I is equal to 5, we get 5 squared. And then we stop there because the upper part here is 5. So that means we're stopping at 5. Okay? And then, in this case, we could simplify this. So this would be equal to 9 plus 16 plus 25. That would total 50. All right? Okay, so let's take a look at this. I guess now it's the third example over here. So in this case, when you look at the inside part over here, this is just some a with a subscript of I there. So when we go to describe this sum, it's going to be a1 when I is equal to 1 plus a2 when I is equal to 2 plus a3 plus a4 plus a5. All right. So if we take a look at example 1 is asking us to write in sigma notation and evaluate the sum of the terms 3 to the I for I ranging from 1 to 5. So when we write this guy out, this is going to be sigma, because sigma means sum. I is going to start at 1, it's going to go to 5, and then we're going to write 3 to the I for the inside part. This inside part is called the general term. This is the general term, okay? And then when we want to find the sum, that's just going to be 3 to the first power plus 3 to the second power plus 3 to the third power plus 3 to the fourth power plus 3 to the fifth power. And you can calculate that using your calculator, and you're going to get a number. I think you get 363. Okay. Uh, let's take a look at example 2. In example 2, this time they give us a sum of, in this case, 1, 2, 3, 4, 5 numbers. And our goal is to write this sum in sigma notation. So the first thing I would say is that we know that we're going to write sigma, and I'm going to have my I go from 1 to 5. See, I know this simply because I have 5 terms. When I look at this, to me, it looks like we have 1 over probably some expression. And when I look at the denominators over here, first of all, I can think of this first term as being 1 over 1. And when I look at these numbers, I notice that 1, 4, 9, 16, and 25, these are really perfect squares. So a moment's thought helps you realize that this is 1 squared, this is 2 squared, this is 3 squared, this is 4 squared, this is 5 squared. So when I write the expression down, the general term, this is going to be I squared. So we could check our answer real quick, right? Because we could just write out the first 5 terms of our sigma notation. That's going to be 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared plus 1 over 5 squared. And then, you can see that we're going to get exactly this sum up top here when we simplify. So we have certain rules for sigma notation, and I want to tell you what those rules are now. So when we look at the sum of uh, a constant added to itself n times, that's just going to be n times c. And if you think about it, we're really doing c plus c plus c plus blah, blah, blah plus c. We're doing that n times, right? So n c's literally means n times c. Okay. The second rule that we have is if you have every term in your sum is multiplied by a constant, you can factor that constant out. So we can factor the constant out like this, okay? If you have the infinite sum, and that involves two sort of general terms there, you can split your sum into 2 pieces. So you could add all the AI's together first, and then add all the BI's together. All we're doing here is we're basically just rearranging and regrouping the terms. Just like you could do it for the sums, you could do it for the differences. So we're going to have the summation as I goes from 1 to n. This would be AI. This time would be minus the sum as I goes from 1 to n of the BI. Just like before, we could write everything out and then rearrange it and regroup it. For this last one, what we can do with this last one is what we're trying to say is we could take the sum as I goes from 1 to n, and we can actually split it into 2 separate sums. We could pick some number k in between, and we put a k here, and we could put a k plus 1 down there. And this is provided, of course, that k is between 1 and n. All right, so this is just basically splitting off the first k terms into one sum, and then having the rest of it, the tail part, be the rest of the sum. Okay, so this next little part here, I think this is a typo. So let's scratch this guy out. These are, I guess we're going to call them sum formulas. These are 3 formulas that we're going to need to be able to execute our approximating area problems. And if you add up 1 plus 2 plus blah, blah, blah plus n, there's a formula for what this is. This is n times n plus 1 divided by 2. So you may have seen that in pre-calculus. If instead of just adding them together, if you squared them first and then added them together, you would get n times n plus 1 times 2n plus 1, all divided by 6. And lastly, if instead of squaring all the terms, you cubed all the terms, you would basically get n times n plus 1 divided by 2 quantity squared. So we're going to need these formulas to solve problems in the future. So I just wanted to tell you about them right now. All right, everyone, take care.